Hello, my name is Jackie.
Hello, my name is Jackie. I chose
at the
the article Postsynaptic Mad Signaling at the
Neuromuscular
Junction
because
to review. I chose this article because it is somewhat related to the thesis project I am working on right now with Dr. Sokowski, and I also kind of found it relatively interesting.
So just as an introduction, synapses are constantly being remodeled, whether it's during development or throughout life, either from environmental responses or genetic changes. This plasticity has been studied in connection to learning and memory. The Drosophila neuromuscular junction has been used extensively to study changes in synapses. And one important function of the neuromuscular junction is to keep synapse homeostasis. There is evidence for both anterograde, which is the forward signaling, and retrograde, which is the backward signaling. This particular study looks at retrograde signaling and specifically the BMP This pathway involves the phosphorylation of the presynaptic transcription factor, MAD, which with a few more steps ends up in the nucleus to activate the TGF-beta response. The author's purpose is to study the TGF-beta signaling pathway to show that when MAD is phosphorylated, the receptor TKV is targeted. In normal neuromuscular junctions in Drosophila, there are synaptic vesicles with glutamate located at the active zone and the presynapse. These active zones are also called IGL-URS, or inotropic glutamate receptors. Cluster on the opposite side of the T-bars, and they contain synaptic boundaries. Mutations on the TGF-beta signaling pathway usually shows a decrease in the amount of synaptic boundaries. Some of these mutations include GBB, SAX or SAX, WIT or MAD. You can see when the authors mention these mutated genes when the words are in italics. One opposing mutation that is opposite of the previous ones mentioned, DAD shows the opposite effect and induces synaptic growth. So here you can see a very basic because my all that up to par diagram of what the TGF-beta signaling pathway does, or what it looks like. GBB is released from the muscle, it then binds with WIT and TKV or SAX, but we're going to use TKV in this example. After that, a whole bunch of signaling cascade occurs. This is still being studied, so I included just a few arrows to go past that. MAD then gets phosphorylated and turns into PMAD. PMAD then combines with media, and that leads to finally the gene expression that we were talking about. In order to study the transduction of the signaling pathway, the authors needed to study what machinery was integral. Real-time PCR, or RT-PCR, was used to review the signaling. The authors were able to find TKV, a receptor for TGF-beta ligand, at the neuromuscular junction. They were labeled with HRP, or horseradish peroxidase, and CSP, cysteine string protein. CSP, cysteine string protein, it was additionally found that TKV is specifically targeted to the SSR, which is the subsynaptic reticulum, clearly seen in Figure 1E on the right. These results were consistent with the idea that retrograde TGF-beta signaling Figure 2 does not feature here, shows additional support for the TKV
shows additional support for the TKV
receptors are activated downstream by MAD, and MAD accumulates at the postsynaptic SSR. It was also shown that PMAD, which is phosphorylated MAD, accumulates in the muscle nuclei. This supports the idea that signaling takes place in the muscle. To support the previous study of PMAD flies were next
When the MAD mutation was present in the gene, only a small amount of PMAD, phosphorylated MAD, was measured in the muscle nucleus. The results of Figure 3, as you can see on the right, provide evidence confirming a transducing event that occurs in the muscle. The TGF-beta signal at the neuromuscular junction causes MAD activation by postsynaptic. These levels of MAD signaling in the postsynaptic terminal was only able to be seen in real-time with GFP MAD as the target. The results of the FRAP experiment,
recovery after photobleaching can be seen here.
GFP MAD is very much concentrated in the nucleus. And as you can see, GFP is being used
About
as the
50% of cytoplasmic
About
MAD
50%
moves
of
to the nucleus
cytoplasmic
upon
MAD
phosphorylating
moves to the
during
nucleus
the signaling
upon
pathway.
phosphorylating
In
during
fact,
the
we see
signaling
that
pathway.
PMAD that
In
is
fact,
bound
we see
is
that
immobile
PMAD
and
that is
cannot
bound
bind to
is
other
immobile
transcriptional
and
factors.
cannot bind to other
Using
transcriptional
this method,
factors.
rates of MAD
Using this
accumulation
method,
can be
rates
measured
of
and
MAD
seen in
accumulation
different
can be
mutations
measured and
to
seen in
analyze their
different
effects.
mutations to analyze
With
their
the
effects.
TKV kinase active
With the
mutant,
TKV kinase
import and
active
export rates
mutant,
of MAD are
import
higher
and
as
export
compared
rates
to
of
the
MAD
control.
are higher as compared to the
Further
control.
data implies that the increase
Further
in net
data implies
nuclear
that the
accumulation
increase
of
in
MAD
net
during the
nuclear
signaling
accumulation
cascade
of
can
MAD
be
during the
explained by
signaling
a
cascade
decrease
can
in
be
the export
explained
rate.
by a decrease in
In
the export
resting
rate.
synaptic kernels,
In
5%
resting
of
synaptic
nucleus
kernels,
GFP
5%
MAD is
of
immobile.
nucleus GFP
This
MAD
is suggesting
immobile.
low levels of MAD
This is
signaling.
suggesting low levels of MAD
Furthermore,
signaling.
some larvae were incubated with a
Furthermore,
high
some
level
larvae
of
were
potassium
incubated
to
with
study
a
the
high level of
effects of
potassium to study
postsynaptic
the
stimulation
effects
on the
of
import and
postsynaptic
export
stimulation
kinetics.
on the import and export
It was seen with
kinetics.
more calcium.
It was seen with
There was
more
more
calcium.
immobilized GFP
There was
MAD,
more
leading to the
immobilized
conclusion
GFP
that
MAD,
this
leading
increase
to the
suggests
conclusion
that the
that
levels
this
of MAD
increase
signaling is
suggests that the
also
levels
increased
of
during
MAD signaling
synaptic
is also
transmission
increased during
and
synaptic
depolarization
transmission
of the muscle.
and depolarization of the muscle.
Transcriptional factors are triggered in response to the TGF-beta
Transcriptional factors are
through the
triggered in response
phosphorylation
to the
of MAD.
TGF-beta
This then
signaling
affects
through
the
the
rate of the
phosphorylation
nuclear
of MAD.
import and
This
export
then
rates.
affects the rate
There
of
are
the
two different
nuclear
rates that are
import
being
and
studied
export
here.
rates.
The import and
There are
export
two
rate of
different
MAD
rates that
and
are
the
being
import and
studied
export
here.
rate of
The
PMAD.
import and export rate of
The
MAD
authors
and the
propose a
import and
model,
export
as
rate
can
of
be seen on the
PMAD.
left, that captures
The
the
authors
effects of
propose a model, as can be
phosphorylation
seen on the
rate
left,
changes
that
on
captures
the
the effects of
flow of MAD molecules
phosphorylation
into the
rate
nucleus.
changes
Once
on the
again,
flow
seen
of
on the
MAD
left in
molecules
figure
into
5.
the nucleus. Once again, seen on the left in figure 5.
Obviously, if rates are being studied, kinetics is an important part of the study, and authors developed this equation, which is shown above, to study the import and export rates. The equation depends on the concentration of MAD and PMAD in the nucleus and their export rates. It was observed that import rates of PMAD is about twice as small
An
and observed net flow into the nucleus upon phosphorylation is caused by a decrease in the export rate of MAD rather than by an increase in its import rate into the nucleus. So in conclusion, it was found that BMP-type TGF-beta signaling ligands are essential in retrograde signaling. There are 4 lines of evidence for this that the authors provide. First off, It was seen that key components of the TGF beta signaling pathway were found in muscle, primarily in SSRs, and these include MAD and TKV. Second, opposite the active zones of the presynapse, phosphorylation of MAD occurs. Following occurs. The third note was found that MAD-mediated signaling can take place in the nucleus. This is seen with the retention of some nuclear MAD. Finally, in the fourth, when the muscle is stimulated with potassium currents, targeting and signaling of MAD is increased. The state is consistent with the existence of an anterograde event that is initiated in the presynaptic terminal. Phosphorylation of MAD decreases nuclear export of transcription factors, and thus also its accumulation in the muscle. Nuclear PMAD must mediate transcription control of target genes in the signaling pathway. FRAP was an excellent tool and was used to reveal that the size of the immobile fraction relates to the higher levels of signaling can be associated with a larger MAD and higher import-export ratio. They speculate that PMAD associates with other cofactors in the nucleus with slow binding and unbinding. When engaged with macromolecules, PMAD cannot exit the nucleus, and PMAD becomes immobile. They also speculate that upon synaptic transmission of neurotransmitter, the neurotransmitter is released with other neurotransmitters together acting as a growth factor for the presynapse. This supports the theory that synaptic is important for growth. Thus, in conclusion, postsynaptic TGF beta signaling does occur in the neuromuscular junction, and there is coupling between muscle stimulation and postsynaptic TGF beta signaling. I hope you enjoyed the summary of my article. I hope you guys have a happy and safe rest of the semester, and thank you for listening.